Hello, everyone. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, the Science and Technology channel.
Yep, and we're having a kind of a retraction story today. Not totally, but a little bit about a story that we did a while back. So
yeah, scientists changed their minds. So what you're looking at right now is the planet Saturn, with the rings, and its biggest moon, Titan, which Titan is about the size of our Earth. They made some different hypotheses, and you can see the different exaggerated bulge configurations. Now they think it's slushy, icy interior rather than an ocean. So let's get to it. Titan's hidden ocean may be more slush than sea, according to a new look at Cassini mission data. That icy, gooey interior could still host warm pockets of water, potential sweet spots for life, like microbes. A new look at spacecraft measurements collected more than a decade ago suggests Saturn's largest moon, Titan, probably does not contain a huge planet-wide ocean of liquid water beneath its icy crust, as earlier research proposed. Instead, going below Titan's frozen surface may mean encountering additional ice layers that transition into slushy passages and isolated pockets of meltwater closer to the rocky core. The study was published on December 17, 2025 in Nature. Would you like to know more?
Early interpretations of data from NASA's Cassini mission pointed toward a large subsurface ocean on Titan. But when scientists built computer models that included a global ocean, the results failed to match the physical characteristics indicated by the observations. A reanalysis produced a different picture that is far more slush heavy. The work could encourage similar reevaluations of other worlds in the solar system and help refine the search for life on Titan.
Yeah, probably they use the AI.
Yeah.
Okay, quote, instead of an open ocean like we have here on Earth, we're probably looking at something more like Arctic sea ice or aquifers, which has implications for what type of life we might find, but also the availability of nutrients, energy, and so on, said Baptiste Jonot, a University of Washington assistant professor of Earth and Space Sciences. Okay, you take the next one, Scott.
The study was led by NASA with collaboration with Journo and Ulla Jones, UW, is that University of Washington?
Yep.
Graduate student of Earth and Space Sciences in his lab. Well, okay, Cassini began in 1997 and operated for nearly 20 years, returning extensive information about Saturn and its 274 moons.
Say that one more time. How many moons?
274 moons. That's a lot. Now, I think we've talked about that too, right? Are there some people that are saying maybe they aren't all moons? They might just be meteors.
If they're captured in Saturn's orbit, then it's a moon, no matter its size, I guess. I don't know.
Okay. Titan, hidden beneath a thick haze, is the only place besides Earth known to have liquid on its surface. With temperatures around negative 297 degrees Fahrenheit, that surface liquid is not water. Instead, methane collects into lakes and also falls from the sky as rain.
Yeah, we've reported that before. Don't light a match on Titan because it'll blow the whole thing up.
Yeah.
All right. As Titan travels around Saturn on an elliptical path, researchers observe that the moon stretches and compresses depending on its changing distance and orientation relative to Saturn. In 2008, that pronounced flexing led scientists to argue that Titan must have a massive ocean under its outer ice because a fully frozen interior would be hard to deform.
Quote here, the degree of deformation depends on Titan's interior structure. A deep ocean would permit the crust to flex more under Saturn's gravitational pull, but if Titan were entirely frozen, it wouldn't deform as much. That's stated by Journo. Is that how you pronounce that?
Journo.
Excuse me. Going on with the quote, the deformation or deformation we detected during the initial analysis of the Cassini mission data could have been compatible with a global ocean, but now we know it isn't the full story. Oh, boy. Okay.
Yep. The new study adds an important detail that earlier work did not fully account for: the timing of Titan's response. Titan's changing shape trails the strongest part of Saturn's gravitational pull by about 15 hours. That delay matters because it takes more energy to move a thick, viscous material than a freer flowing liquid, similar to how a spoon meets more resistance when stirring honey than water. By measuring this lag, scientists could estimate how much energy is required to reshape Titan, which in turn reveals clues about how viscous the interior must be.
You know, they go to home on Friday night thinking that there's an ocean there, and they wake up Monday morning and decide that whole thing was just ruined. That's just too
Blows
bad.
their mind. Yeah.
Yep. The amount of energy lost or dissipated inside Titan turned out to be far higher than researchers would expect if a global liquid ocean were responsible. This quote, nobody was expecting very strong energy dissipation inside Titan. There was the smoking gun indicating that Titan's interior is different from what was inferred from previous analysis, said Flavio Patrica, a postdoctoral student at NASA's Jet Propulsion Laboratory, Jet Propulsion Laboratory, who led the study.
Flavio. It's like interesting. Yeah. Rather than an open, planet-spanning ocean, the team's preferred model contains much more slush and considerably less liquid water. The slushy material is thick enough to account for the 15-hour lag, while still holding water that allows Titan to deform when Saturn's gravity pulls on it.
Patrica reached these conclusions by tracking the frequencies of radio waves sent from the Cassini spacecraft during those close flybys of Titan. Journeau supported the interpretation using thermodynamics. His research focuses on how water and minerals behave under extreme pressures, information that helps scientists evaluate whether other worlds might support life.
Quote, the watery layer on Titan is so thick, the pressure is so immense that the physics of water changes. Water and ice behave in a different way than seawater here on Earth, Journeau said.
At his planetary cryo-mineral physics laboratory at UW, Journeau and colleagues have spent years developing techniques to recreate alien conditions in laboratory experiments. Using that work, he provided Patrica's team with a data set describing the expected physical properties of water and ice deep inside Titan.
Quote, we could help them determine what gravitational signal they should expect to see based on the experiments made here at UW, Journeau said. It was very rewarding. The discovery of a slushy layer on Titan also has exciting implications for the search for life beyond our solar system, Jones said. It expands the range of environments we might consider habitable.
The idea of a broad underground ocean once energized the hunt for life on Titan, but the researchers argue, that's not good, that the updated picture could actually improve the chances of detecting it. Analysis suggests Titan's freshwater pockets could reach 68 degrees Fahrenheit. In smaller volumes of water, any nutrients would be more concentrated than they would be in a vast ocean, which could make it easier for simple organisms to grow.
Scientists do not expect to find fish moving through slushy channels. Still, if life exists on Titan, it could resemble polar ecosystems on Earth. Journeau is part of the team for NASA's upcoming Dragonfly mission to Titan. I didn't know about that. Scheduled to launch in 2028. The findings from this work will help shape that mission, and Journeau hopes the future data will deliver both evidence of life on the planet and a clear answer about whether Titan has an ocean. Let's send somebody there.
Stay tuned, right? Yeah. Hopefully they'll get this thing figured out, and we'll figure out whether it is or it isn't. So it's all good.
Right, folks. Thanks for joining us. We'll catch you tomorrow.
Take care, everyone. Thank you. All right.